Hi everyone. In today's lesson, we'll be covering our second day of section 5.4, and today's lesson will be about the antiderivatives of exponential functions. We start today with a definition. It says let u be a differentiable function of x, and if we have the antiderivative of e to the x dx, it will just be equal to the function e to the x plus c. But if that exponent on e is anything other than an x, it will require a u substitution. So if we take a look at number 1, we have e to the 6x plus 4 dx. So we're going to start by just letting u be equal to the exponent. And if we take that derivative, we get du is equal to 6 dx. Or if we divide by 6 on both sides, we get 1/6 du is equal to dx. I'm going to rewrite my integral, and then we'll talk about how we're going to do the substitution. Okay, so if you notice, right here we have e to the 6x plus 4, and that will be rewritten as e to the u. And then we have dx right here, and dx is going to be replaced by 1/6 du. So we're going to have 1/6 du in the place of that dx. So our integral will become 1/6, can go out in front, of e to the u du. When we take that antiderivative, we'll have 1/6 of e to the u plus c. But don't forget, and sometimes we do forget to do this, you have to replace u with 6x plus 4. Don't forget that step. So we have 1/6 e to the 6x plus 4 plus c. And that's our final answer. Okay, in our second example, I'm going to call your attention to the two parts in here. We have 4x, and then we're multiplying by e raised to the negative x squared dx. Now notice that the problem is written with a negative exponent, and that means that our final answer can have a negative exponent. All right, so typically what we do is we let u be equal to the exponent on e. So we're going to say u equals negative x squared, and that means that du will be equal to negative 2x dx. However, in the problem, I see a 4x right here and dx. So I'm going to take my negative 2x and multiply it by negative 2. And multiply the other side by negative 2 as well. So we end up with negative 2 du is equal to 4x dx. Okay, so let me rewrite this a little bit. So the antiderivative of 4x e to the negative x squared dx. So this portion right here will be rewritten as e to the u. And then the 4x and dx will be replaced by negative 2 du. Okay, so let's do all that substitution. So remember that 4x and dx are being replaced by negative 2. Don't forget your integral sign, du. So that took care of this and this. And then we have e to the u. All right, we're taking the antiderivative of e to the u, which will just give us e to the u. Now we need a plus c. And then do your substitution. Replace u with what it's equal to in the very beginning. Substitute it back. So we have negative 2e to the negative x squared plus c. Final answer. Okay, so again, typically in these problems, we are going to be letting the exponent on e be what u is equal to, so we can get these in the form e to the u. There are, of course, some exceptions, okay? All right, so we're going to set u equal to 1 over x, And we're going to rewrite that as u is equal to x to the negative 1 before taking that derivative. So now du will be equal to negative 1 x to the negative 2 dx. Or du is equal to negative 1 over x squared dx. Okay, so with a little bit of rewriting can help you see how these two are related. You may want to divide by negative 1 on both sides and write it negative du equals 1 over x squared dx. Okay, so check this out. If I kind of rewrite this integral as e to the 1 over x times 1 over x squared dx. I just split that fraction into a product, okay? And I'm doing this to help you see that substitution. So e to the 1 over x becomes e to the u power because u is equal to 1 over x. 1 over x squared dx is equal to negative du. And when I rewrite that, we're going to pull that negative sign out in front of the integral sign. We have e to the u du. So we have the negative sign out in front, and then we have the antiderivative of e to the u du. And that's simple. The antiderivative of e to the u is e to the u, and then it's plus c on the end. Okay, do your substitution, replacing u with 1 over x. Don't forget the plus c, and that's our final answer. All right, one thing I just want to remind you of, like for all of these problems, you can check your answer by taking the derivative, okay? Okay, number 4 is a little different because we just have e to the x, so it wouldn't really make sense to let x be equal to u, okay? It wouldn't make any difference on the problem. So what we're going to do actually in this one is let u be equal to 1 plus e to the x. In other words, the way I look at it, that's the more complicated part of this problem. So u equals 1 plus e to the x. That means that du is just simply going to be equal to e to the x dx. And hopefully you can kind of see that in the problem. I'm going to rewrite it to help you see it. This is 1 over 1 plus e to the x times e to the x dx. Okay, so the first part, the 1 over 1 plus e to the x would become 1 over u. And then e to the x dx, there it is. That just gets replaced by du. So we have the antiderivative of 1 over u du. And hopefully you remember from earlier on in the chapter that the antiderivative of 1 over u du is equal to the natural log absolute value of u plus c. So that will be natural log absolute value 1 plus e to the x plus c. Don't forget that absolute value sign. So we're going to take a little hint from what we did on the last problem where we ended up with a 1 over u, and we are going to let this denominator right here be our u, because then hopefully we'll be able to get this rewritten as 1 over u times something. All right, so let u be equal to 2x plus e to the negative x, and take that derivative, and let's see if we get it close to what's in the numerator. The derivative of 2x is 2. The derivative of e to the negative x will be e to the negative x times the derivative of the exponent, which is negative 1. And we need a dx on the end here. And with a little bit of rewriting, we have du is equal to 2 minus e to the negative x dx, because we have a positive times a negative right there. And if you check it out, that's our numerator. Okay, so do a little bit of rewriting. So you have this as the antiderivative of 1 over 2x plus e to the negative x times 2 minus e to the negative x dx. Again, looking at our substitutions, this would become 1 over u, because u we set equal to that denominator, and then 2 minus e to the negative x dx, that's our du. So we have, when we rewrite it, the antiderivative of 1 over u du. And again, the antiderivative of 1 over u du will give us the natural log, absolute value of u plus c. And don't forget that final substitution, get the u out of there. So it'll be natural log, absolute value, 2x plus e to the negative x plus c. And that's our final answer.